Hello, Geometry A students. It's me, Tim again. Today we're going to be covering the Unit 4 activity. This one has to do with similar triangles. Again, please follow along. Write down the things that I write, put down the things that I ask you to put down. And if you need additional help, I'm always available. My email, you can email me at any time. It's ttrigg@ofy.org. So email me anytime if you need additional help, if this wasn't enough to help you through the activity. All right. Well, with that being said, let's get right to it. So I have the Unit 4 activity already up. Let me go ahead and share my screen. All right, there we go. Hide this. Okay. So first we're going to talk about angle criterion for similar triangles, part 1. Okay, so first thing it says, create a random triangle ABC, measure and record its angles. Pretty simple. So you're going to go to this GeoGebra link, go ahead and click that link there, and it should bring up GeoGebra. And we're going to make a random triangle. So what we want to do is on the top on this toolbar here, you're going to go to this one right here. This is the polygon tool. So go and click that, click polygon. And then you want 3 random points. We're just going to create a random triangle. It doesn't matter what it looks like. So here we go. Connect it back together just like that. So here's our triangle ABC. And what they want from us is they want to know the angle measures of the 3 angles within here. So what's the measure of angle A? What's the measure of angle C? What's the measure of angle B? Okay. So to do that, we go back up to this toolbar and you'll see this tool here. Click that. Go ahead and click the first one, angle. Then we're going to go ahead and click the sides. Okay. So click this side, then this side, and that'll give you the measure of angle B. This side, then this side, gives you the measure there. This side, then this side gives you the measure there. You don't have to make your triangle like I made mine. You can make your triangle any which way. And you can move around the points if you don't like these numbers, you know, whatever. Okay. So what I would say is be careful. Sometimes it likes, if you click kind of this way, then this way, it'll give you the exterior angle. So you just want to make sure if you get the exterior angle, just undo it and then click the sides in the opposite order. And then you'll get the interior angle. That's the one we want, the interior angle. Okay. Can't really see that. Move that there. Okay, cool. So we have angle A is 50.03, angle B is 30.9, and angle C is 99.07. You might have different numbers. Whatever numbers you have, you want to put them in this table. Okay. Now, notice it says, like for the first one, angle ABC. So that's going to be angle B in this. So angle ABC is actually this one right here. Okay. So for me, that's 30.9. Okay. So whatever angle measures you have, I want you to go ahead and fill them out in this table. You're going to have different numbers possibly than me, and that's fine. That should be done. Okay. So now we want to draw a line segment DE of any length anywhere on the coordinate plane, but not on top of the triangle. Okay, so I need a line segment DE. Okay, I might zoom out a little bit here. I want to move my triangle kind of out of the way. And I'm going to make my segment DE. I'm going to go ahead and make it in this quadrant here. Okay, and it could be of any length, it says. So I'll just kind of make it not exactly like AC here, but enough so you can kind of see that it belongs to that. So maybe like this. So it's kind of going the same way as AC, but it's clearly not the same. Choose one of the angles of triangle ABC. From point D, create an angle of the same size as the angle you chose. Then draw a ray. Okay. Then draw a ray from point D through the angle. should now have an angle that is congruent to the angle you chose in triangle ABC. Okay, so I'm going to choose angle C here, and I'm going to make that like here. Okay, so how do I do that? Well, we can go ahead and click this, click on angle with given size. So I want it to be the same as that. So I click this, and I want it to be, what's the measure of the angle? 99.07. Just like that. You see how it makes the same angle? Same angle measure. And that's what we want. Okay. Now we want to make a ray that goes through that. So they give you the point here already. So we want to make a ray like that. So when you go to this tool, this set of tools, you go down to ray. Click ray, click D, then click E prime like that. Okay. So this should form the same angle as we have here. Okay, cool. What's our next step? So we now have an angle that's congruent to the angle from triangle ABC. Okay, create a point anywhere outside the mouth or opening of the angle you created. The point will initially be named F by the tool, but you should rename it G. Now draw a ray from E through G such that it intersects your first ray. Creation should be a closed shape resembling a triangle. Okay, so let me read that again. Create a point anywhere outside the mouth or opening of the angle you created. The point will initially be named F. Okay. Now draw a ray from E through G. Okay. Okay. So I need another point outside of this. So I'm going to maybe put it maybe here. Okay. And they want us to rename this as G. So if you go ahead and right click on that, you can rename it, and we want to rename it as G. Now we create a ray through E and G. So we've created a triangle. Okay, I think that's what they want. So we have two rays intersecting, and we have an angle that's the same as this angle. Okay, cool. Label the point of intersection of the two rays F, and then draw a triangle DEF by creating a polygon through points DE and F. Okay, so we're going to call this intersection point, we're going to call it F. So go ahead and click on that. Oop, we don't want that. Click on the point tool, that's this one here. Click that. Click on the intersection, and it should be labeled as F. Okay, now we want to create triangle DEF. So go back up to the tools, go to the polygon tool, DEF, and then back to D. Now we've created a triangle. So you can see we've created a triangle. You can move some points around. This one you can't move around because it's based on this angle. This one you can move around. Okay, great. Now click on point G and move it around. By moving point G, you can change the angles. Okay. Okay, cool. So now we want to take a screenshot and put it right here. Okay, so now we've accomplished our goal. So now we have a triangle that only has one matching angle. Right? The other angles don't match these ones. And you can see that if you go to the angle tool, angle, you click here and here, creates that. Click here and here, creates that angle. You see the measurements. And you see they don't match these ones. Only angle D matches angle C. Okay. So they want you to take a screenshot of this. So if you have the snipping tool, you can go to snip, new. Hopefully this works. It didn't work on the last unit, but maybe it'll work. Copy and Control V. Control V. No, that's not going to work. So what you might need to do is you might need to save when you take the screenshot. Just save it. So File, save it, and then once you save it, you can you can insert it from here. So you do insert image, you go to my computer, or you choose the file, or you drag it onto this, and it'll bring it up. Okay. If you're having trouble with that, you could always let me know. But yeah, the image should be here. Okay, it'll look something like this. Obviously, mine looks different, and yours might look different, and that's fine. Okay. In GeoGebra, label the measure of the angles of DEF. We already did that. Then move point G around the coordinate plane and produce triangles with different sets of angles. Record at least 5 sets of angles as you move G. So you can see I've got these angle measures. So this is angle. The first angle they want is angle DEF. DEF is this angle here. So in my case, that's 21 degrees. I'm going to go ahead and put 21 here. And kind of look at the middle letter when you're figuring out which one. So in this case, it's at the E. Here, the middle letter F. It's going to be right here. So that's 59.93. 59.93. And this one, 99.07. For this one doesn't change. Because if I move this around, if I move point G around, it's going to change two of the angle measures. But it won't change this one, angle D. So this one will be at 99.07 at all times, while these two can change. So I want you to move G, and you'll get different measurements. Go ahead and put those different measurements here. This one will still be 99.07 for all of these. So they want you to at least do 5. So if you do 5 rows of this, that'd be great. Okay, if you want to do more, you could do more. Okay. Part D. By moving point G, how many triangles is it possible to draw, keeping the measurements of just one angle consistent? How many instances are all 3 angle measures of triangle DEF equal to those of the original triangle? You can make infinite triangles by moving point G and changing 2 of the angles. You will be able to produce infinitely many different triangles. With different angles. All right. Only one triangle, one of those triangles, will be congruent to triangle ABC. Moving on, part E, to decide whether 2 triangles are similar, is it enough to know that one pair of corresponding angles is equal? Okay, so here we have 2 triangles, and one of the angles are congruent. But does that mean that the 2 triangles are similar? No, they're completely different. They're completely different triangles, right? They don't even look the same, and the other angles don't match. Okay, so these are not similar triangles, despite the fact that they have one angle the same. Okay, so one angle the same is not enough to prove similar triangles. I want you to go ahead and explain that there. So that one set of congruent angles is not enough to prove that the triangles are similar. Okay, I want you to go ahead and say that there. Okay, next page, we are on. Okay, AA criterion for similar triangles, part 2. All right, create a random triangle ABC, measure and record its angles. Okay, I'm just going to use the same triangle ABC. You can produce a new triangle if you want, but I'm just going to use the same one. So I'm going to use those same numbers, and you would put them on this. So whatever the angle measures you have, you're going to put them there. Okay. Choose 2 of the angles on triangle ABC and locate the line segment between them. Draw a line segment DE parallel to the line segment you located on triangle ABC. You can draw DE of any length and place it anywhere on the coordinate plane, but not on top of triangle ABC. So the main difference here is that DE needs to be parallel. Okay, so I'm going to make DE. I want it to be parallel to AC. Okay, so I'm actually going to delete what I had here. Get rid of this. Get rid of this, all of this. Okay. And I want to make sure DE is going to be parallel to AC here. How do I do that? Well, you can go ahead, I'll just put a point. So I'm actually going to move this point. D is going to be like A. So D is going to be A. And then E will be like C. Okay, so now, after you have your point D, along the top, you'll see this tool here, this list of tools. Go ahead and click that, and you should see parallel lines. Go ahead and click parallel line. And do I have parallel segment? No. Okay, so you have to use parallel line. So we want to select the point D, and then select this line. So what we've produced is a line that is parallel to AC. Okay. Once we have that, I want you to go back to this point tool. Go ahead and click on that. Click on the point and click somewhere on this line. And this is going to be our point E. Okay. Okay. So now we have a segment DE that is parallel to segment AC. Okay. Cool. From points D and E, create an angle of the same size as the angles you chose from triangle ABC. Then draw a ray from point D and a ray from E through the angles such that the rays intersect. You should now have two angles that are congruent to the angles you chose from triangle ABC. Okay, so let me see if I can make sense of that. So I want to make an angle from this point that's the same as this angle here. Okay, so what we're going to do is go to the angle tool, that's this one here. Go down to angle with given size. So that's the second one down. Click on that. Now we want to select point E. Select this. Oh, that's not what I want. Back. Okay, select point E, then select we want it to be the same as the other one, 99.07. Okay. That doesn't seem right. That doesn't seem right at all. Let's go back a second. Let's go back to here. Click the segment tool and connect E and D. So it should just look darker here. From here, go to the move, the arrow. And let's go ahead and get rid of this line. Yeah, that's good. So now we have DE that's still parallel to AC, and we don't have the whole line. We just have DE, and that's good. Okay, maybe that'll help us. So then go to angle. I'm kind of learning this with you guys. So we want to select leg point, vertex, then enter size. Leg point. Leg point. Okay, let's try that. There we go. Okay, so I clicked the point, then clicked this segment. Okay, that was a little tricky. And now we want to produce a ray. So go to this tool here, go to ray, click on that, click here and here. So now we've got a ray, and the angle is the same as angle C here. So the angle here at angle E is the same as at angle C. Okay. Now we want to do the same thing over here. So we want, go to angle with given size, same as before. Click point D and then this segment. And this time we want it to be the same as this. So that's same as angle A. So that's going to be 50.03 in my case. You might have different angle measures, but Didn't produce what I wanted. Let's see. So maybe I need another ray from here. That maybe. Let's try that. Click here. Okay. Oh, that's what I want. Maybe click here and here. Okay. That looks good. That looks good, I think. Can I move this? No, I don't think that's what I want. Angle with given size. Here to here. Okay. No. Given size from here to here. Oh, that's very close. But I want it on the other side, so do that. So we're going to do the same thing. Angle with given size. Click E, then D. Then you want to do clockwise. Okay, there we go. Cool. So now let's go back up here. We're going to go to the ray tool. And I'm learning this with you guys. I'm not an expert in GeoGebra. I'm sorry. I thought I worked out how to do this before, and I've done this before, but you know, sometimes it just doesn't work out. Okay. So now we've got a triangle. Great. Label the point of intersection of the two rays point F. Okay, so I need to go to the point tool, point. Click the intersection, it's point F. Cool. Take a screenshot, put it here. Okay, record the angle measures. So we have the two angle measures. And then we want to know what this angle measure is. So we will go ahead and click on this again. Go to angle, not angle with given size, the regular angle. Click that. Click here and here. Oh, we don't want that. That's not the one we want. Click here, then here. Oh, we don't want that. Click here, then here. That's okay. That's the correct angle measure. Even though it's showing it's the same as that. Okay, they're both the same measure. So that's fine. And it should match this as well. So that's how you know you did it right, is all the angles should match all the angles from this one. So that's good. Now I want you to record those angle measures right in here. And remember the DEF is this one, DEF. So that's this one. So that's 90.07, 99.07. Record the others here. Pause the video if you need time to do that. Okay. How do the angles of triangle DEF compare with those of the original triangle? So you would say that they have the same measures. Okay, so the angle measures from DEF match the angle measures from triangle ABC. So you want to put that there. Okay, with two of the angles fixed on triangle DEF, what do you notice about the shape of DEF compared to triangle ABC? These two triangles are the exact same shape. But they are different sizes. In other words, the two triangles are similar. Cool. Period. All right. Take any side of triangle DEF and find its length. Find the ratio n of its sides to the corresponding on ABC. Okay, so what we need here is I'm going to go ahead and click on this polygon tool just so we can make our triangle. Just like that. And what they want to know is side lengths now. So side lengths. So on the toolbar, go to where we have the angle, click that, but I want to go down to distance or length. So click distance or length. And we're going to click on all the stuff we want to know the distance for. So for this triangle, I want to know all three side lengths. So click each of the three sides, and you'll have it'll pop up numbers like that. We want to do the same over here. Click, 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 click. Okay. If you need to move things around a little bit, go ahead and click on this arrow tool. See how it's kind of like on there. You might want to move that so you can see clearly what these are. Okay, great. So what it asked us to do was create a ratio between one of the side lengths here and one of the corresponding side lengths here. So what that would be is you do, for example, if I did AB over DF, like that. Oh, actually, they want the DF on top. So we would write, go ahead and pull up the equation editor. And again, you get here by clicking on this right here. Okay, click that. And so you'd say something like n equals, and we want a ratio. So we want to do this length, DF, this length, 14.63 over 9.65. Now, if your numbers are a little bit different, if they're completely different, that's fine. Okay, that's fine. So whatever you go ahead and put that in the calculator, and whatever you get as an answer, go ahead and put that there. Your numbers will be different, and that's good. Okay, so I'm going to go ahead and figure out what this is. So 14.63 divided by 9.65. Okay. And we're going to do it right here. So what were my numbers? 14.63. I'm going to do divided by 9.65. 9.65 equals. Okay, so I'll get some number. In this case, it's 1.51, but that 1 will round to a 2 because that's 6. So I'll say 1.52. 1.52. Okay. Cool. Just like that. All right. Dilate triangle ABC about the origin using a scale factor n. Measure and compare the lengths of the sides of the dilated triangle ABC with those of DEF. Take a screenshot of your dilation, save it, and insert the image below. Okay, so what is that going to look like? Okay, so go back to GeoGebra. Go back to GeoGebra, and we want to dilate triangle ABC by this factor. Okay, so I'm actually going to grab this entire thing because I don't just want 3 decimal places. I want like the whole thing. So I'm going to go ahead and copy that. And then on your tools here, I want you to go to this tool here, the line with 2 dots away from each other. And we're going to go to dilate from point. So you would select this triangle, and then you want to select 0, 0. Oh, it didn't do anything. Okay, get off that tool. Go to the point tool. Go to the point tool, go to point, and click 0, 0. Okay, it's important we have that point available to us. So you're going to have to make a point here using the point tool. Now let's go back. So go back to where we were. That's this one. Go to dilate from point, click the triangle, click the point, And then where it says factor, this is where you put in this value. Okay, whatever your value is. In my case, it's that. So I already copied it, so I'm going to paste it there. Just like that. All right, it's hard to see what's going on, so I'm going to go back to the arrow and just kind of scroll out. Okay, now notice my triangle. Notice my triangle A prime, B prime, C prime, and my triangle D, E, F. Notice the side lengths, they're the same as over here. So you notice this is like 11.36 and this is 11.35. Slightly off. That's okay. This one's 14.63. This one's 14.63. This one's 7.61, 7.61. I don't know why that one's different. That's weird. Rounding error, I guess. That's okay. They should be the same or very close to the same. And you'd put those values in here. So in this case, it says C prime, A prime. That's this one here. So that's 7.61. Yeah, 7.61. And over here where it says like DE, which one's that? DE is also 7.61. Okay. And you would just fill out these with whatever numbers you have. Your numbers probably won't match mine, and that's good. So just put those in there. Okay, great. Oh, and I think and they also want a screenshot. So make sure you get a screenshot. In my case, it would be this, but whatever yours looks like. The sample answer looks like this. Okay. What can you conclude about triangle A prime, B prime, C prime, and triangle DEF based on their side lengths and angle measures, or both? So I want you to say that the two triangles, triangle A prime, B prime, C prime, and triangle DEF are congruent because they have the same angle measures and the same side lengths. They're completely congruent. Okay, that's what I want you to put there. Part I, explain why there must be a sequence of rigid transformation that maps the two triangles together. Well, because they are congruent, because the two triangles are congruent, here, there will be a series, or I guess I should say sequence of rigid formations that maps one triangle to the other. All right, cool. And then they want you to perform it. So in our case, how would I go from triangle A prime, B prime, C prime to triangle DEF? It would just need to translate. You need to move that triangle down and to the right. So I'm not going to get too specific, but in my case, I would say to map one triangle onto the other, I would have to translate triangle A prime, B prime, C prime down and to the right. That's good enough. I don't need to get specific like how much down and how much to the right. Now yours might be a little different. Yours might be up and to the left or down and to the left or whatever. So, just make sure, in my case, I would have to move it down and to the right. Okay. Why do I keep on going here? Go away, calculator. I might need that calculator later though. Okay. Based on your responses for parts H and I, what can you conclude about the two triangles? I would just say there's a one-to-one similarity transformation, meaning that the two triangles are congruent. Oh, wait, we're not talking about A prime, B prime, C prime. Okay, I would just say that the two triangles are similar because they're the exact same shape, just different sizes. So I want you to explain that there. Two triangles would be similar because they have the exact same angles and they have proportional sides. They are similar. Part K, that's the last part on this page. To decide whether two triangles are similar, is it enough to know that two pairs of corresponding angles measures in the triangle are equal? So in this case, yes, because we forced two of the angles to be the same as two of the angles here. And once we force the two angles to be the same, it automatically forced the third angle to be the same. You can see that here. Okay. So that's what we want to say, that when you force two angles to be the same, it'll force the two triangles to be similar. So if two pairs of angles are congruent in two different triangles, then the two triangles will be similar. Cool. So yes, that's good. Page 7. My goodness, this is a long activity. I don't know how you do this on your own. Okay. Side angle side, criterion for similar triangles. Okay, create a random triangle, ABC, record the lengths of two of the sides and of the triangle and measure of included angle. Okay, so I'm just going to go back all the way until we just have our first triangle, triangle ABC. We use that same triangle we had before. It doesn't really matter. You can make a new triangle if you wish. But we only want two side lengths. We need to know two of the side lengths and an included angle. Okay, so actually, let's go to this tool right here. And you want to go to distance or length. And we're going to click on these two side lengths here. Okay. For now, I want you to go back to the arrow tool and we're going to not show object on these. Okay, they're still there, but for this one, we just want two side lengths and the included angle. So notice it's two side lengths and the angle in the middle between them. That makes it side angle side, which is what we want. Take a screenshot, put it here. Great. All right. Draw a line segment DE of any length and place it anywhere in the coordinate plane, but not on top of triangle ABC. Find and record the ratio of the length of this line segment to one of the corresponding lines. Okay. So like we did before, I'm going to create, I want you to go to segment, go and click segment. We're going to click and click. Okay. Now notice I kind of made it going the same way as AC, but it's not exactly the same way. That way it's easier to see what corresponds to what. All right. And find and record the ratio of the length of this line segment to one of the corresponding line segments on triangle ABC and record it. You recorded in part A. Excuse me. So I need to know this length. So go back to distance and length here. Click on that. In this case, this length is 6.02. This one's 5.02. So we want to record the ratio here. Okay, so I need that calculator again. Okay, calculator. Cool. Go ahead and we're going to do 6.02 divided by 5.02 equals. Okay, so there's our ratio, 1.1992, blah, blah, blah. Great. Now multiply the ratio you calculated by the length of the other side of triangle ABC that you selected in part A. Record the resulting length. Okay, so this other side length we found, the measure for, the 7.49, we're going to multiply it by this value. So we're going to go ahead and multiply by 7.49. Now you might have different numbers, and that's okay. So in my case, it's 8.982, blah, blah, blah. Yours might be different. Okay. Locate the endpoint on DE that corresponds to the vertex of the angle you chose in part A. Using that point as a center, draw a circle with a radius equal to the length you calculated in the previous step. So what they're asking us to do is now go to the circle tool. That's right here. Click that and go to circle, center, and radius. Click on that one. Click on point E because point E corresponds with point C. And the radius is going to be this length that you got here from your last calculation. So I'm going to copy that and I'm going to paste it here. Now what I've created is a circle that has the same radius as this. Okay, cool. From the center of the circle, draw a ray at an angle to DE, make the angle congruent to the angle of triangle ABC that you measured in part A. Okay, so first thing I want to do is we want to go back up to here. We're going to go to angle with given size. Click on that. Okay. Then you want to click D, then E. And the angle that we want is whatever this angle is here. So in our case, that's 99.07. We want counterclockwise. Okay. So then it produces that. And now what we want to do is go to this tool right here. Click on that. We want to go to ray. So we went down to the ray right here, ray. Click E, then D prime. Okay. And there's a lot going on. Hopefully I'm not going too fast, but it should look something like this. Mark the point of intersection. I'm going to label it as F. So go to the point tool here, point, click there. It should be F. Now what you want to create is triangle DEF. So go ahead and click on this, click on polygon, D, E, F, then back to D. Now what we should have created is a triangle, like this. Next. Take a screenshot. Take a screenshot, put it right here, and there you go. Measure all the angles on triangle ABC and DEF. Okay, so you're going to find all the angle measures for all the triangles here. So again, on the toolbar, go up to this. I want to go to regular angle. Then you could start finding the measures. Click here, then here, click here, then here, click here, then here, click here, then here. You should notice that the angles have the same measure, but I want you to record those angles on this chart. Okay. Next. Does a relationship exist between measures of the angles? Yes, they have the same measures. So then the two triangles must be similar. Okay, so put something like that. Yes, the triangles have the same angle measures. Therefore, the two triangles are similar to each other. Okay, put something like that there. Part E. Your constructions for the triangles were unique. Based on the random nature of this activity, what conclusion can you draw about the similarity of two triangles when two side lengths are proportional, but the same ratio and the included angle is congruent? Okay. Well, what we can conclude is that if two side lengths of two triangles are proportional. And the included angle is congruent. And the two triangles will be similar. And again, similar means the same side, the same shape, but not necessarily the same size. You can see that here. These two triangles are the same shape, but they're not the same size. Okay. All right, cool. And these two triangles are similar. All right. Ooh, last page. Here we go. And this one has a part E. Okay. Create a random triangle. Ooh, one more random triangle. Well, I'm just going to use the same triangle again, triangle ABC. So I'm going to go back, 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 back until I just get triangle ABC. And I'm just clicking this undo right here. All right, I have my triangle. Cool. I don't want the angle measures, so I'm going to go and hide those. So it says show object. So you can go ahead and go to this arrow, right click on the angle measure, click on show object, and it'll unclick it like that. So I don't want the angle measures. I only want the side lengths. So go to this tool here, go to distance or length, click that, click the side lengths, and then you'll know the side lengths of your triangle. All right. So now we have we have a triangle, we know its side lengths. Great. Put those side lengths here. So in this case, AB side length. In my case, that's 9.65. Yours might be different. Whatever the values are, you put them here. Great. Okay. Here's the hard part. Draw a new line segment, DE, of any length and place it anywhere in the coordinate plane, but not on top of the triangle. Same thing we've done before. So go to segment, go to DE. Again, I'm making it kind of so that it corresponds with AC, but not completely the same, okay? Not completely the same angle, not completely the same length. Okay. Find the ratio of the length of this segment to the length of one of the sides of triangle ABC. Record the ratio. Okay, here's where we might need the calculator again. So go back up to the tools, go to this tool right here. We want distance or length, and click that side length. So in this case, this length is 7.42, this length is 5.02. So we want to divide that there. So 7.42 divided by 5.02. Okay. So what we've got is 1.4 whatever. Okay. So this is the ratio of those two side lengths. Cool. Now it says multiply the ratio you calculated by the lengths of the other two sides of triangle ABC that you selected in part A. Record the two resulting lengths. Okay, so I would need to take this ratio that we got earlier, this calculation, and we're going to multiply by this side length here, 7.49 times 7.49. Now, you're going to need this number later, so you might want to hold on to it, write it down on the side or something. So in this case, it's this, 11.07 whatever. Okay, I want you to go ahead and copy that. Copy. And since it was this side length, you're going to go from this vertex here, and you're going to create a circle with center through point. No, actually circle, center, and radius. Yeah, that's what we want. Center, circle, and radius. Click on that. Click on E. The radius will be that calculation you just got. Okay. So that's a circle centered at point E that has a radius of this calculation. Okay, cool. Now remember when I said you might need that number again, you're going to need it right now. So what we're going to do is we're going to find, I need to get that number again. So I'll divide those. Well, maybe I'll go back. Oh yeah, right here. So you can click on this little clock and you can see all your previous calculations. So I want this one here. And we're going to multiply that by 9.65 in my case. Might be a different number for you. And then you'll get a value. So I go ahead and want that value. So I'm going to go ahead and copy this. And let me scroll out a little bit. Let's see what's going on. Okay, cool. Now from there, go to circle, center and radius again. Click on point D, and the radius will be that calculation we just got. Okay. You might be like, well, what in the world is going on here? Well, go to the point tool. So go ahead and click on this one, point. And I want the intersection point of those two circles. So where those two circles intersect, go ahead and click right there. Now we're going to produce the triangle. Go to polygon, polygon tool. D, E, F. Great. All right. I also want to know the side lengths here. So go ahead and click on this tool here, distance and length. Click, click. So that goes to that, that goes to that. Okay. All right, cool. Go ahead and take a screenshot of that. Take a screenshot of that and put that right here. Here's the example they have. Here's my example again. Yours will look probably a little bit different. That's okay. Measure all the angles. Well, I know how to do that. Go to this tool again. Go to angle. Click, click. Make sure you're getting the interior angles. Click, 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 click. Ah. I messed up. Click, click. How is it not working? Click, click. There we go. All right. And do the same on this one. Angle F, angle D, and angle E. Now, notice the angles, they should match, or at least be very close to matching. Notice this one's 30.9, and this one's 30.89. That's close enough. I wouldn't worry about it too much, but as long as they're very, very close to each other. This one's exactly the same here. That's good. This one, almost 50.03, 50.04, pretty much close. That's just rounding error. That's just rounding error stuff. Okay, but they should have the the same angle measures or very close. So I want you to go and put those angle measures here. They should be the same or at least very, very close to each other. Yes, again, you would say that there is a relationship that exists. When all the side lengths are proportional, all the angles will be congruent. And when all of the side lengths, two triangles, are proportional, then the angle measures will be congruent. The two triangles will be similar. Angles are similar. Cool. E, last problem. Ooh. Your constructions for triangle ABC and triangle DEF were unique. Based on this random nature of the activity, what conclusion can you draw about the similarity of two triangles when all three sets of corresponding sides triangles are proportional by the same ratio? I guess it's the same as this, right? Yeah, it's the same answer as this. You might want to word it a little bit different, but I'm not going to bother. Okay, cool. Ah, and we're done. Well, that was a long one. I feel like I'm losing my voice. Okay, I hope that made sense. I hope you're able to follow along. I know that was a long one. I don't know how you would be able to do that on your own, honestly. So I hope you're able to get through it, or at least some of it. If you still need help, please email me. My email again is ttrigg@ofy.org. All right. So farewell, geometry students, and good work. I'll see you next time with the Unit 5 activity. Goodbye.